Welcome to this episode of Robert's Creative Chronicles. So today we are going to solve this question, which states that a cantilever beam 2 meter long is subjected to a gradually varying load from 0 at the free end to 2 kN per meter at the fixed end. Find the values of maximum shear force and bending moment and draw the shear force and bending moment diagrams. So first let's draw the beam. This is the fixed end of the beam. And this is the free end. So this is the free end point B and fixed end point A. So the question says it carries 2 meter long. Let's write the meter first. 2 meter long. Is subjected to a gradually varying load from zero at the free end. From 0 at the free end. This is the free end to 2 kN per meter at the fixed end. So the gradually varying load is from 0 here to 2 kN here, which is the fixed end. So at this point, it is 2 kN per meter. And here is 0 kN per meter. So here is the beam. And now we can do the calculations. So now we'll start with the shear force calculation. Shear force diagram. So the shear force at point B is given by FB, is given by the formula Wx squared over 2L, where L is the total length of the beam and X is the distance from point B to any distance before A. Once it reaches the length of A, it is X turns to L. So at this point, X at the free end, X is 0. So 0 times all this equation gives us 0. Gives us 0. So this is 0 kilonewton. So the shear force then at point A, the formula becomes at point A, as I was saying, at point A, X becomes L. So the formula now becomes WL squared over 2L. So L reduces to what? WL over 2. And remember to put negative since we are using the downward convention. And we are going to draw a shear force and bending moment diagram below the x-axis. If we were drawing the shear force and bending moment diagram above the x-axis, we could have used it without adding the negative sign, but we are drawing ours below it, so we must add the negative sign. So this becomes negative 2 times 2 over 2. So it now becomes what? Negative 2 kilonewton Fa. So this is our maximum shear force. Negative 2 here at this point, at point A, at the fixed end, At this point, we have our maximum shear force and also even maximum bending moment. So now we'll do the bending moment calculation. Now this SFD stands for shear force diagram and this BMD stands for bending moment diagram. So the calculation, the bending moment at point B, which is the free end, is what? Is given by the formula that's negative WX cubed over 6L. So at B, as I said before, at B, X equals 0. So this becomes what? 0 kilonewton meter. Now, the bending moment at point A is also given by this equation, but X equals to L at point A. So it's negative WL cubed over 6L. So it becomes negative WL squared over 6. So MA is what? Negative 2 times 2 squared over 6. Negative 2 times 2 squared over 6 is negative 1.33. Negative 1.33 kilonewton meter. So this is our maximum bending moment at this point A. So now we can draw the shear force and bending moment diagrams. So to draw the shear force diagram, we will project these points down and point B down. So now we will draw the base to represent this line AB. So this will be our A, this will be our B. Now the shear force, the value of the maximum shear force is 2, negative 2. That's why we're coming down. Could have been positive 2, would have gone up. But since it's negative, we are going below the x-axis. So here we'll draw a line. So this will represent our 2. This will represent 2 kilonewton. Then from this point, you draw a parabolic curve to join here with a French curve. So like this, we'll draw this parabolic curve. So we can write minus here to indicate our convention, negative. So now this is the shear force diagram. And then finally, we will draw the bending moment diagram. So the bending moment diagram, in the same way, we'll draw a baseline. So this represents A, this represents B. This is the fixed end, this is the free end. Then our maximum bending moment, that is our bending moment at A, is 1.33. So we'll draw a line in the same way to represent 1.33, and we will write 1.33 here. This represents 1.33 kilonewton. As I discussed in my other videos, you can use a scale to get this dimension, this line. Okay, this is actually kilonewton meter. You can use a scale of 1.33 kilonewton meter to represent 1.33 centimeter. or you can use 2 kilonewton meter to no 2 kilonewton to represent 2 centimeter. Any one you want to use, but the length you are going to use here represents two kilonewton. That's why I'm writing 2 kilonewton here, and this 1.33 kilonewton meter. So I'm just trying to tell you that this length, the reason for this length is to account for this bending moment, and likewise this one to account for this shear force. So the same way, this one, the curve you are going to use to represent bending moment is a cubic parabolic curve. So you look for a very a part that you look for a part that enters deeper like this. This curve is actually more inclined deeper inside. So this is a cubic parabolic curve. So you make the curve, just make it a little deeper than this, but both of them are parabolic curves. But this one is a cubic parabolic curve. So this is negative, and this is the bending moment there. So this is the shear force diagram, and this is the bending moment diagram. And this is the values of maximum shear force and maximum bending moment. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.